All right, just let me know when we should get rolling here.
Yeah, sure. People are joining in. Just a couple of minutes more.
Do you guys have an external link I could share with our team?
Yeah, sure. Just a second.
Cool.
Yeah, here you go. Come through, guys. Just a few minutes more before we start the session. Sam is here already. Just waiting for a few more people to join in.
All right, yeah, just let me know when we should get going. I'm here.
Yeah, just a minute, I think.
All good. Yeah, you turned the camera off. I just wanted to make sure that wasn't like a go for me.
No.
So you can keep it on. You can keep it on.
Yeah. Sure. Okay, now just a minute more and we'll get started. Okay, let's get started. Welcome everyone. Thank you for joining us for today's workshop. We have with us today Sam Flamini from Superfluid. Thank you so much for taking this time out. With Sam, we'll be talking about how to integrate money streaming into your applications. Feel free to ask questions down in the Q&A tab and Sam will try to answer your queries. Without further ado, let's begin the workshop. Over to you, Sam.
All right, hello everybody. Thank you for joining. I'm pretty excited to talk to Superfluid with you guys today. The way we'll structure this is just going to be a quick overview on what Superfluid is to start, and from a high level perspective, how it works. Then we'll go through some examples of how to use our SDK to interact with the protocol using JavaScript in either a Node environment or just like from a React app. And then finally, we'll go through a pretty quick smart contract example as well, where we'll build something pretty cool. So we'll do that. Hopefully we'll have a good solid like 5 to 10 minutes at the end for Q&A. but I do think that at least one member of our team should be inside the chat for you to ask questions to. Looks like we had questions if everyone can hear us. Okay, it sounds like audio is good. If audio is a problem, just let us know and someone can flag me. Okay, without further ado, let's go into Superfluid. So let me share my screen. All right, can you see my screen? I'm assuming the answer is yes. Can I just get some confirmation we can see my screen? Can someone just type yes in the chat? If so, yes. Okay, fantastic. So Superfluid. Okay, what is Superfluid? Superfluid is a protocol for digital native programmable cash flows. So this means we allow you to stream money with no capital lockups in a way that is 100% programmable and on-chain. So we believe that the internet is to information. The metaphor is the internet is to information, but blockchain is to value, right? So this is one of the things that got me personally really excited about Superfluid. When I learned that, like, when it really got through my mind that we can do things that we do with other forms of information with money, right? One thing being streaming that money, it made me really excited, right? And it made me excited because in the rest of the world, or even in the digital world, services are provided in real time, but payment isn't always provided in real time for those services, right? If I'm providing you an API, if I'm providing you a subscription service, or if I'm providing you my services as an employee, I'm providing you that service in real time. Why shouldn't I be paid in real time as well? It's 100% technically possible for that to happen. And, you know, Superfluid is one of the ways to do that. So money streaming, right? What is this concept of streaming money? Well, a money stream is a form of continuous payment that is a frictionless and open-ended connection between two accounts, right? So what this does is it creates that really cool link between service provision and value transfer. It allows you to provide the service and get paid in real time for that service. And the other cool thing that happens here is because all of this is on chain, you have this really cool like idea where payment terms can be essentially embedded into these agreements that live on chain. So when you create a money stream, you basically just decide, you put a parameter in for who's going to be the receiver, what super token you're going to use, and then what the flow rate is going to be. And that just lives on chain, right? It's verifiable on chain. You don't need an intermediary to facilitate this transaction. There's no unpayment risk because, again, it's on chain, and there's no delays because you're getting paid in real time. So in terms of efficiencies that come from money streaming, what we allow you to do is essentially just automate recurring payments, right? You can open up a stream with a single transaction, and that stream will just stay open indefinitely unless you decide to change it with another transaction. And this is cool because if you think about it, like if I'm paying for a subscription service once a month, or if I'm paying a DAO contributor or an employee once a month, over the course of a year, that's 12 transactions, right? With the money stream, that could be just one transaction, right? Where the money just flows in real time to my recipient throughout the year, instead of in discrete intervals every single month. And the cool thing here as well is that there's no capital lockups. So you're not required to lock capital into a separate contract that can't be used throughout the year. As long as you have tokens in your account, that stream will stay open. So one of the questions we always get when we bring this up is, how does gas work with this, right? And I'll explain this in more detail, like at the protocol level in a moment. But the high level question is, do I have to pay gas every second as funds are streamed? If value is transferring every second, like, why am I not having to pay gas every second? Don't I need to pay gas? The answer is no, you don't need to pay gas every second, right? We do a bit of black magic at the protocol level here, where we can use the flow rate and block.timestamp value to calculate user balances in real time. And we'll explain more about what this means as I discuss the rest of the protocol. But the cool thing you get here is that, you know, you get this real-time balance, right? This thing that's constantly flowing up and down, depending on what's happening with the flows. So what we can do is we can look at all of the streams, you know, coming into a particular user's account with a given token, and then all of the streams going out of that account. And we can calculate what, at any given moment, a user's balance should be. right? So again, we get lots of questions on how are you guys doing this? How is this possible, right? And we had to do some things at the protocol level that are new, in my opinion, very innovative. And one of those things we did is we built an extension onto the ERC20 and ERC777 standard called a super token, right? So in order to use a token in a money stream, it has to be a super token. Again, it's compatible with all the token functions and methods you're used to, right? These tokens have full compatibility with ERC20 and ERC777, and that they have the balance of function. They've got the ability to transfer, do approvals, all this kind of stuff. But it's plugged directly into the Superfluid protocol, right? There are two types of super tokens. One type is just deployed as is as a super token out of the gate, right? So there are some projects in our community like Ricochet, Miva, and Fraction that have deployed their tokens as native super tokens. However, we know that interoperability is really important in DeFi and crypto more broadly. So we also have wrappers, right? So you can essentially just wrap any ERC20 or native asset you'd like to use as a super token. And what's happening there when you wrap is you're basically just depositing the underlying asset into a contract and being minted a one-to-one correspondence of the super tokens. And then anytime you want to unwrap, you can do that, right? You just get the exact amount you put in back out. The other thing that's happening behind the scenes that's making the streaming functionality possible are something called super agreements. So a super agreement is a peer-to-peer financial relationship, or these are contracts that facilitate these peer-to-peer financial relationships. They're open-ended, they're perpetual, right? When you create a stream, right, it's open-ended, right? I determine how many tokens I'm going to send you, and the stream will just stay open unless I do something. Again, it's on-chain. We mentioned earlier, these are kind of ways to embed payment terms into an on-chain format that is verifiable by, and there's no third party you have to trust. And the third thing, which gets back into our discussion around the super tokens, is that information on for each user and their status within these agreements is built into the token balance, right? Which brings us back to this concept of a real-time balance. So what we can do is we can look at all of the super agreements that a given user is a part of, right? We can see all the flows coming in for a given user for any token and all the flows going out, right? And what we can do is we can look at the block.timestamp value and that net flow rate, which takes into consideration how many tokens are going in and how many tokens are going out. And that flow rate can be positive or negative. And we can just calculate, all right, how much time has passed since there was another update with the user's balance, and what's that net flow rate? And at a given point in time, we can make sure that all the balances are accounted for properly, and that if anyone needs to ever transfer, everyone has the correct amount of tokens, right? So again, that brings us back to our lovely ticking up and down in real-time balance, right? Okay, so moving on, we'll get into some other exciting things. These cash flows can be programmable, right? So there is a type of contract called a super app, which allows you to do things whenever a stream is created into a contract, whenever that stream is updated, or if that stream is ever deleted, right? There are callbacks that can run, that can listen for events and do things, right? They can listen for changes in the cash flows and do things with that information, right? So in a bit, we'll build a really cool super app that, for example, takes incoming streams and then sends outgoing streams to the owner of a contract, right? The contract will also be an NFT, so you can trade it, and once the NFT is traded, we'll also change the flow that we just sent to the new owner instead, as a kind of tradable cash flow. And again, just the thing to highlight here is that you can place arbitrary logic inside of these callbacks, right? You can place logic inside of this after agreement created callback. So you can listen for a stream that's created into the contract, right? Same thing for after agreement updated or after agreement terminated, which will listen for when the stream is deleted. So if we zoom out a bit more, right? What you have here is a lot of streams going from user to user, right? Then you have streams going into apps, right? Like super apps. And then you have streams going back out from super apps back to users, which might be going to pay for subscriptions. you have all these cash flows bouncing off of each other. And eventually you get what we're excited about, which is this network of cash flows. So there are millions and millions and millions of dollars worth of streams flowing on Superfluid right now. And we're already seeing this happen. Like, this is a visualization we took of just a small portion of token volume that's real, like each node is an account, right? And you can see the connections between each account are, those are streams, right? You can see this continuing to grow and continuing to get more valuable over time. So yeah, you guys, if you guys build on Superfluid, you are building the early applications that can capture a lot of value here and help create a lot of value here. So we really encourage you guys to use some of the information we give you today to build really cool applications. All right. So getting more practical, we have 10,000 in prizes here for Eternals, 10,000 USD. 4,000 will go to the top project built on Superfluid. 3,000 will go to the top financial innovation built on Superfluid, and $3,000 will go to the most futuristic hack. Right, so that's an open-ended one for you guys to surprise us. To be eligible, just make sure you use Superfluid in some way, use some of our smart contracts, use one of our SDKs, and you'll qualify. Today, what we'll do is we'll go through the Superfluid SDK. Right, we'll show you how to create, update, and delete streams very easily on the front end. We'll go through the Superfluid console, which is a really useful developer tool for just getting information on the protocol. And then we'll briefly use our visual dashboard as well, just to make sure that you guys know it's there and that you guys can also use that. So, all right. That's a brief overview on what Superfluid is. I hope that's helpful. Looks like Yao is answering some questions in the chat there, and I'll be able to come back in and review some of those as well at the end. All right. So what I will do here is pull up my browser where we can run through some examples. This is our repo. We'll come back to this in a bit. But I do want to first go through how to use the SDK to interact with the protocol directly, right? So here in our docs, we have a really helpful section called Interactive Tutorials, where we go through how to initialize the SDK, which is quite important. And then we have sections for using different various parts of the protocol directly. So we have like all these inline examples with Code Sandbox, where you can just run code here in the browser or open it up as a separate tab. And what we'll do right now is go through how to create, update, and delete a flow. And I'll show you how to do examples where you just have an unlocked account, right, with the private key, kind of like just there. Imagine you own the private key. You can just send streams from yourself, which is helpful in a node environment. And then I'll also show you an example to use with like MetaMask or a browser wallet. Okay, so creating a flow. I will open this up in a new tab. I believe I have this right here. Okay, hopefully you guys can see this a little bit. Let me zoom in quite a lot. All right. Hoping you guys can see this here. So basically what you have is an example of the initialization of the SDK, creating a signer with ethers and the SDK, and then we're sending a transaction to create a flow. Okay, and we have a nice helpful front end component here as well to help us out. So what we're doing in this function, this main function that's providing the logic, is we're taking in a recipient address, we're taking in a flow rate, which is the amount of tokens you want to send per second in way, and we are initializing the framework, we're getting a signer, and we're running this create flow operation. So this is how you initialize the framework here. This SF variable is being created with this framework.create pattern, which will give us the network. We pass in a network name, we pass in a provider. Here I'm using ethers, so I just pass in an ethers provider that I define in config.js. And then we create a signer. We have a private key exposed here. I recommend probably not doing this. This private key has no value associated with it. It's just for the sake of example, right? If you steal all of my test tokens, that's not cool. Please don't do that. I'll have to mint some more. And then here I just have the address of DIAX, which I use to create the flow as well. But creating a flow is this simple, right? You create this create flow operation here, and then we sign it. But all I'm doing is I'm calling sf.cfav1.createFlow. I'm passing in the flow rate, the recipient, and the address of the token we're going to use. Okay. and we just log some helpful stuff down here. So let me grab an address that I know we can use to, this is fake ether, by the way. This is fake. This is not real ether. All right, I'm not a whale out here. We can paste in an address. We can put in a flow rate. And then what we do here is we just calculate the total dollar value per month for you. So you can see this, right? But again, this is the number of tokens you're sending in way per second. So I'll create the stream. We're creating a stream. Lovely. Our stream was just created successfully there. And now we can use Superfluid developer tooling to actually see this. So we can go to the Superfluid console and go to the network we're using. In our case, it's Coven. Let me zoom in a lot more for you guys. That might be too much. All right. So you can see we have this docs testing address. I've added this to my address book in the console, which you can do. Like if I paste in any address, for example, like if I paste in the address I just used, this is, I think, called my address 1 on Polygon. I've added to my address book there, but you'll see all the addresses come up on the networks you've used them on. You can add them to your address book. In my case, docs testing address is added to the address book, and we can see information on it, right? So we can see, all right, we have a few streams. We can see when they were created in terms of incoming streams. We also have outgoing streams. So one outgoing stream was just created 57 seconds ago. And that was the stream that we just created on the front end. So if I click on the stream details, we can see some information about it. All right, it was sent from the docs testing address. It was sent to the address I just put in. We can see information on the flow rate per day, and we can see the amount streaming in real time. If we want as well, we can also view this on a subgraph explorer. So I can click on this, and we'll see a subgraph explorer pop up where I can just click play and get like very helpful information that I might even want to use in my own application, right? So this, you can use this to create inspiration for your own queries you might need to use in your own applications. All right, so we've just created a flow. We verified that we did that. Now let's go in and update a flow. And updating a flow is very, very similar to what we just did. The only difference is we're just calling update flow instead of create flow. The parameters are the same. You can pass them in the same order. Let me just do this as an example. So let me paste in the address we just sent this to. Okay, we're gonna enter a flow rate per second. Let's double it. Okay, so we'll send 51 DAB per month instead. Okay, let me expand this. All right, this was also successful. We can go back into the console. Again, I can go back to Coven. I'll click on docs testing address again, and we'll find this. And let me refresh one time. This usually takes a second just to index because we're getting data from the graph. Saying it was last updated 2 minutes ago. Again, this just tends to take 1 second. While this loads, I'll show you an example of how to view this on our dashboard. And we can see here that this actually did update in our dashboard. So this is the Superfluid visual dashboard. Right? This is just found at app.superfluid.finance. It's another useful tool for you to use as you're working with the protocol. You can open up streams yourself here just from a front end. Like you can just click buttons and open up a stream instead. And you can see here the stream we had that was sending 25 per month is now sending 51 per month, right? We can see this here. I can get information on it. And by now, the console should update. Yep, we can see this is now doubled. It was created 3 minutes ago, but it was last updated 1 minute ago. There we go, wonderful. Finally, what we'll do is we'll just delete a flow. And again, this is really simple. We just need to pass in a single address to delete. The syntax is a little bit different in that we just have to pass in the sender receiver in super token. No flow rates necessary when you're deleting. But let me just paste in our address. Deleting our stream. Boom, our stream has been deleted. We go back up to the dashboard and refresh here. In a second, this will propagate and we'll get information that the stream was indeed deleted. Looks like this was just deleted here. We can see 13 seconds ago, stream deleted. And we can see stream was canceled here as well. Okay, so that's creating, updating, and deleting. I'll do one more quick example showing a MetaMask specific example here. So here what I have is let me make sure that I'm connected to the right address here. Make sure I'm connected to that docs testing address that has quite a few tokens. Let's connect our wallet. Make sure I've got the right wallet open. Yep, okay, wallet's connected. Let's enter in a recipient address. Let's enter a flow rate per second. Let's pick a new rate now. Let's do 3x here, so it's even bigger. Send more tokens. 77 tokens per month. Let's do that. All right, now MetaMask modal pops up, and we can confirm that transaction. You'll see here inside of CreateFlow.js, I have the example you need to use for any kind of MetaMask connection. Again, this can all be found in our docs. This is all open code. Just scroll down to the MetaMask Web3 provider example, right? You can literally just take this code, fork it yourself, and use it in your own applications for this hackathon. Okay, so one last time, go back into the console, and we'll see, okay, we have a 2 token per day flow rate. Again, it's about 3x what we did initially. And we can see that, all right, 25 seconds ago, a stream was created successfully. Okay, so that is creating, updating, and deleting streams using the SDK. Quite easy to use. To wrap this up on the presentation and content level, I'm gonna go in and I'll show you how to create a very simple super app contract that deals with some programmability around this stuff, and show you where you can find that example as well to use in your own projects. So the code we're going to use, I pasted it in the chat a while ago, but the code we're going to use is at the protocol mono repo. It's in a new branch, I believe, right now, but it will be pushed into our main repo in just a second. It's the Tradable cash flow hard hat branch and examples, and you'll be able to see it in this Tradable cash flow hard hat example. Okay, so let me just send this to you in the chat. And yes, I just saw the chat. A stream is a cash flow. Yes, the stream is it's a flow of money being sent in real time, right? So when I send a money stream, basically what I'm doing is instead of sending normally you pay $10 per month and you send it every month, you click a button and all 10 tokens are sent. What you can do with the stream is you're basically dividing that $10 per month into little tiny increments, and you're sending it gradually second by second, right? So a little portion of that $10 per month is sent every second. Can it be based on time like minutes? No, the value is transferred in real time every second. But you can customize to send a certain number of tokens per minute, right? It's just math you have to do, right? If you have a certain amount of tokens you want to send per minute, you just have to do the math to figure out, all right, so how many tokens do I need to send per second to get that per minute rate? All right, I'll come back and I'll answer more questions in just a second. Okay, so I have this repo up locally. Let's expand quite a bit here. All right, I'm in our example. Let's zoom in quite a lot. All right, so this is an example we call a tradable cash flow. So what is the tradable cash flow? The tradable cash flow is a contract that is two things in one. One, it's an NFT. Many of you are probably all familiar with NFTs, right? So you can see here, this is an ERC 721. All right. The second thing that it is a super app. So this redirect call contract is going to give us our super app functionality. You can see that this inherits from super app base. And a super app is one of those apps that can have those callbacks on it, which can listen for events that happen in streams and let you create programmable cash flows. We're using some other helpers here. So there's a CFA library that lets you create streams very easily in Solidity. So you can create streams with basically almost exactly the same kind of syntax you saw in the SDK in Solidity. And what's happening inside of the redirect all contract? Let's clean some stuff up here. And I do have to zoom out a bit so I can show you this. But what we're doing is we are defining, among other things, who the receiver is going to be initially, right? So we're going to set the receiver as the owner of the contract initially. And that will be the person that's the beneficiary of all streams that are sent into the contract. So this contract is going to receive streams, and it's going to send 100% of the value of those streams to the contract's owner. Okay, so in order to do that, we have to look at the callbacks, right? So because we need to redirect all the streams to the owner, we need to do things inside the callbacks to make sure that that logic actually happens. So once an agreement, after agreement created, once the stream is created into the app, we need to update the outflow of the app such that 100% of the inflow is going to the owner. And then if the stream is updated, we then need to also update the outflow coming out of the app to the owner, because if we are decreasing the amount of tokens sent into the contract, we also need to decrease the amount of tokens sent out of the contract. And then finally, once the agreement is deleted, we need to also delete the stream going out of the contract. Okay, so inside update outflow, what we're doing is we're just going to check. We're going to get what the flow rate is into the contract. If the flow rate into the contract is now, if it exists and it's now 0, we need to delete the flow. If it exists and it's not 0, we need to update the flow. And if there's no stream at all into the contract, we need to create a flow. Simple enough. The other thing we need to make sure that happens is if this NFT is transferred, we need to delete the flow to the old owner and create a flow to the new owner. So 100% of the funds should be not sent to the old owner, and 100% of the funds should now be sent to the new one. So this change receiver logic will help us do that. So there's an on token transfer, I believe, or before token transfer method we use inside of the ERC 721 that lets us do this, but this is the logic that'll run, right? So we delete the flow here on line 142 to the old owner, and then we create the flow here on line 144 to the new owner. Again, simple enough, not too crazy here. So in order to deploy this contract, you can go into the deploy folder. There's a deploy script using the hard hat deploy library. Again, you can see all of this stuff in the repo and use it yourself. And there should be instructions as well on how to run it. So what you can do when you have this deploy script written is run npx hard hat deploy. Then I'm going to specify the network as Coven that I want to deploy to. Okay. So this is taking just a second. We're compiling and deploying, but you can see here, it's pretty simple. The syntax here for deployments, you just pass in your arguments is what you want to pass to the constructor. And this helper library will deploy the contract for you. Okay, so we have the contract's address. And then here in the scripts folder, I've got a few really helpful scripts that let you interact with the contract you just deployed. So we can test to see if this works. If I send funds into it, will it send them out to the owner? Okay, so I've made the owner of the contract this address here, which I also have access to, so we can check it. And if we copy this address, we can go into our scripts and run our create, update, and delete flow scripts to make sure this works, right? So in this createflow.js file, we can see this format looks quite similar to what we already saw because we're using the SDK to interact with this contract. Okay, so we're creating a flow, and what we're doing here instead of using the sf.cfa.createFlow method, we're using just the this helper on individual tokens. So if we know we want to only send one token typically, we can get the token contract using this helper called sf.loadSuperToken. We can pass in the token address. In this case, all the test tokens we have, we call them F and then the token symbol. So this helps us load the DIEX contract, which is SuperToken DIE. And then we can just call DIEX.createFlow directly on that DIEX contract, and this will work. So we're going to create a flow with this flow rate into our contract. Okay, so if I run the script using this line here, this will create this transaction for us. And we can go back in just like we've been doing before with the console and make sure that it worked. Right, so these are the kinds of workflows that I'd almost expect you to use as you build on Superfluid. That's kind of why I'm going through them like this, because this is kind of what like legitimate Superfluid developer would do. COVID sometimes takes a second here. These transactions can stick a little bit. Okay, looks like this was successful. So if we copy this address and we go back out to the console, I can paste this address into the console. We can see this is an account on Coven. It's got streams on Coven. And we can see here that it is receiving a flow and it's sending a flow out. And we can see that these match, right? So 100% of the value being sent into the contract is now being sent out of the contract. So this is working as intended. We can also see that the receiver is the address that I set to use, right? So this is the owner. We can see that this address is the same as what I have here. So again, working correctly. Now, if we run our other scripts, right? So our update script, again, the parameters are almost exactly the same. I'm just going to paste in the new address. And I'm just going to change this to update flow. We'll be able to make sure that the outflow is updated to have the same flow rate that we just set here in update outflow. Okay. Again, Coven can take a second. Transactions kind of stick. All right. So if we refresh our console, all right, we're sending a lot more tokens because we just updated it. Fantastic. And this is matching, right? We can see the inflow and the outflow is the same. Finally, we can delete. So this is just completely nuke our flow. I'll run delete here. And we'll change the script to delete flow. And then while we're waiting here, let me pull up another helpful thing to maybe see. You can maybe just verify that the NFT is also minted. So here I have a separate browser up with that address that I'm setting as the owner. Go to assets, and let's maybe add a token. All right. Yep, we can see here, there's no decimals. All right, the TCF token, we actually have it, right? So if we zoom in a bit, we can see that this address here is actually, it's got the NFT. The NFT was minted to it, right? So we can also verify the NFT functionality is working as well. All right, so if we check here one more time, this should all be 0 because the flow should be deleted. Yep, flow rate is 0, both match. And this worked as intended. So that's a very simple super app. That's like base level stuff you can do with programmable cash flows. You can imagine that tradable cash flow by itself can be really useful. It allows you to send streams into NFTs and turn NFTs into these productive assets, right? So we'll encourage you to play around with that. I would also encourage you to play around with the rest of our examples. So you can see we've got some other stuff. If you're more DeFi inclined, this stream and call option is pretty interesting. If you're more front-end inclined, we have some examples of front-end stuff using the SDK Redux, and then just some other helpful stuff up here. So I'll pause. We've got, it looks like 7 minutes or so, maybe a little bit longer for questions. And yeah, we can pause there. But thank you so much, guys. All right, it's time to look at the chat. What's a good page to land on here? I'll just leave it on this money streaming page. Okay. Let's go to the chat. Are batch transactions possible? Absolutely. Yes, they are. So we actually have a section here on batching transactions where you can run batch calls. You can effectively batch a lot of transactions in one. You can do really crazy things like open 5 streams in one transaction, like transfer tokens to 5 different addresses in one transaction. Like you can do quite a bit. And I really would encourage you to go to this batching transactions section of our docs to see like a super simple example of that. Can you pause a stream? So pausing a stream would be the same as just deleting a stream, right? You just run the delete flow. And then if you ever wanted to restart that stream, you just would create flow again, right? Yeah, that's how that would work. Can the total flow amount not flow rate, be changed once the streaming starts. I'm not sure what you mean by that exactly. I'm not sure what you mean. Can the total flow amount be changed once the streaming starts? So the total amount flowed is basically just going to depend on what the flow rate is and how long the stream has been open. So if you needed to like almost dynamically adjust how many tokens per cent, you could do that just by running the update flow calls. But I might need to understand more about what you're asking specifically. What is the consensus protocol? So we are just built as a smart contract framework that is deployable right now on EVM chains. So we're on Polygon right now, we're on Gnosis chain right now, and then we're available on all we're available on the Avalanche testnet, which I think is the Fuji testnet, and we're also available on Arbitrum and Optimism testnets. We want to be lots of places that are EVM compatible to start. That's kind of the goal. So we're deferring on the consensus protocol level. We're deferring to EVM chains. But will it resume or start again in case if we delete a stream? So you can the way that I would recommend if you're trying to pause streams and then restart them, what I'd probably recommend doing is maybe using some kind of off-chain infrastructure to dynamically delete a stream and then after a certain amount of time restart the stream. So there are protocols that are built on top of Superfluid that use keepers to do some things like this. It might help with some like automation for your users if you're trying to consistently start and stop flows based on certain parameters. All right. Can I use Superfluid for subscription-based payments? Absolutely. There's actually a project called Diagonal. I think I can show them here that is going to launch very soon on the back of this use case. And we encourage other people to build their own versions. But restarting the stream will consume gas. In use cases where the stream is based on user usage like video streaming, it will cost a lot. Correct. Restarting the stream will indeed consume gas. To be honest with you, if you're starting and stopping streams, if you're using streams like discrete small streams to pay for very short time intervals, I suppose. I don't know if streaming is 100% the ideal option for you, right? A stream really works when you need to automate a recurring payment that tends to happen over at least a relatively long period of time. And by long, I mean like at least days to weeks, right? Difficult UX, at least with the way things work right now, is like the second a video is streamed, like if it's a 40-second video, like if you have to stream and then delete a stream when the video ends, that's not a great UX, right? Maybe if somehow browser wallets are way more, way better UX and it doesn't require as many transactions or something, maybe it's possible, but those very short time intervals get tricky. How much got paid from MetaMask when you confirm a transaction? That very moment, how much was removed from wallet from MetaMask? So the way it works when you create a stream, you pay very small gas fees. We can look, I suppose. I believe it was this transaction. Let's take a look. It was a really small amount. I mean, it looks like it was like the transaction fee. I mean, it's $0.00 just because the gas price is it's very low on Coven. It's also going to be pretty low on Ethereum L2s and Polygon. What happens though, what is removed from your wallet though, is you have to put up a 4-hour deposit to open a stream. So you have to basically put 4 hours in an escrow account, which you get back whenever you close the stream, right? But what that does is, I can go into a lot of detail on this, but that basically, we have basically a network of nodes that are helping secure the protocol by making sure all streams are solvent, that no one's streaming funds they don't have. And that 4-hour escrow payment you put up or buffer payment you put up effectively serves as a reward mechanism to allow those, like, it's a little bit more complicated and detailed than this, but that network of nodes and teams helping secure the protocol, they get rewarded in the form of that deposit if you forget to close the stream, right? Again, I can expand on that in much more detail if needed. When we wrap a token, are they locked or can we use them anyway? So when you wrap a token, the token you're now using is the super token version of that ERC20. That's usable in other places if you want to, right? Again, it has all of the ERC20, ERC777 functionalities associated with it. The challenge is like, if you want to, we don't have like super token pools in Aave yet, or like in Compound yet, right? So if you want to do things like that, where you're using products that are very connected to the ERC20 standard, at least for now, like you'd have to unwrap those tokens and then deposit those in those pools. How small are the gas fees though? Can you pay gas fees itself as a stream? That's really interesting. Not as things stand now, but there might be some interesting things you can do around like subsidizing gas for your users via like Biconomy or meta transactions and things that might be worth exploring. The gas fees are very small. Like the gas fees are honestly more dependent on the network than the action you're taking. Like for example, like the gas fee here is like, it's really small. It's 2.5 Gwei. Like that's pretty small. Okay, what other questions do we have here? Thank you for all the questions, guys. These are great. Is it possible to integrate it in Django? So Django, as far as I know, I'm not a Python guy myself, but Django, I think, is a Python framework, which gets tricky. We do, however, have someone in our community that's building a Python kind of helper library. I'll see where he's at with things, and he might be able to help you out. Shazur Khan, feel free to DM me. We can discuss the Python, and I can show you a little preview of that Python library. What else do we have here? Got a couple new messages. JS for the win. That's right. JS for the win. It's a love-hate relationship with JavaScript, but it is what it is. Flow rate is based on time factor. Is there any use case where it is not based on time, but some other factor? So just to clarify, flow rate is the amount of tokens you are sending per second, right? It will always, I mean, I shouldn't say it will always because things might change, but like that's what it is. It's per second. If you want, you can build in custom logic where you create options for your users where you abstract like the per second thing away, right? And you might have to build, like you'd have to build your own logic in to say, all right, like if I have a game that I'm building, if a user does this, the stream should be this. Like that kind of stuff is on you at the interface level. But if you mean something different in terms of like a protocol level thing, let me know. Can it be percent based? I'm not sure what you mean by percent based. Again, these kinds of things where you're allowing your users to like do something that leads to a certain flow being created at a specific flow rate. That's up to you to do like inside of your app logic, right? Again, these are very programmable. Like all you need to do is set the tokens per second and it'll work. What you show your users as what's happening to create the certain amount of tokens per second, that's up to you. All right. Looking back through. What is the advantage of sending money streams over batch/discrete payments? Great question. So there are certain scenarios when sending a discrete payment actually does make more sense, right? Like, if I am, I don't know, if I'm buying a business or something like that, right? And I need to put up a bunch of money up front one time, yeah, there might not be a need to stream that kind of thing. If I'm buying like a discrete product, yeah, I'm buying a discrete product. We think that streams make a lot of sense with services more broadly, right? And a service can mean a lot of different things. A service can mean an API, right? Like infrastructure, right? If I'm using infrastructure in real time, it probably makes a lot of sense to be paid in real time or be paying in real time for that. If I'm an employee, think about as an employee, right? Or if I'm a contractor, or if I'm a freelancer, right? And I'm getting paid, would you rather get paid in one lump sum on the 30th every month? Or would you rather get paid little by little as you work, right? So that you're receiving funds as you work in real time. For a lot of people in the world, like payday loans are a gigantic industry because that's how salaries have worked for so long, right? And how paydays have worked for so long, right? If you're able to get paid in real time for the work you're doing, you remove a lot of cash flow problems for the end person, right? Like it's a pretty big deal, like in terms of the employee side alone, right? So there are things like that. Again, services, time-based things that we believe are pretty valuable use cases for streams. What about the equity distribution in companies, for example? Can the ownership also be streamed based on meritocracy and consensus or voting of people like leadership change or community leader change? Yes, absolutely. So there's actually a couple of products in our ecosystem. One of them is called CoFund that's going to launch relatively soon. That this isn't necessarily like in a traditional company sense, but in the like DAO sense, they're tying streams to like the grants process. So if you are in a DAO and you have someone come to you and they propose a new initiative that's going to cost $100,000 over the course of a year, the way this works now is like you vote and then you send the group $100,000, or you agree to send them $100,000 on completion. That's not ideal, right? What CoFund is doing is they're trying to build a system where like you write a proposal, you approve the proposal, you get the proposal approved, and then funds are slowly unlocked to that group over time, right? And every X days, there's a reevaluation, and both sides evaluate like how it's going and the current value of it to the ecosystem if things have changed, and they can update the flow rate at that time as well. So yeah, that's an option there as well. I do think I just froze. Hey guys, can you hear me?
Yeah, we can, but the video is frozen.
Okay, well, at least we've got the audio. I'll answer questions via audio. That's strange.
That's sweet of you, Sam.
Thanks for letting me continue answering the questions as well. These are pretty good.
Sure. Go ahead.
I'm happy with the interactivity. Okay. Going back through these, can a user stop a stream even if the application does not give that option? Yeah, they can. So two things I'll say on this. Number one, you can always, as the receiver, you can always stop a stream as the receiver, right? You can't update a stream being sent to you as a receiver because that would be like you stealing money from somebody else. You can't do that. But you can always cancel the stream as a receiver. And if you're using an application that's built on Superfluid, or one of your users are using an application built on Superfluid, you can go to our dashboard, which is just an open source utility, and see all the streams you're sending and cancel the stream there. Right, so you always have the fail-safe using the Superfluid dashboard, which is open source, to cancel that stream. Yeah, I was correct. You should test our dashboard. If you have 300 tokens in your wallet, can you start a stream of 500 USD? Yes, you can. You absolutely can. As long as you have enough money to cover that initial 4-hour deposit, you can start the stream. And 4 hours, right? Like if you're trying to start a stream for $500 per month, 4 hours worth of that stream is going to be pretty small, right? I think it might not even be a full dollar you have to put up, right? So yeah, short answer is yes. It's the beauty of not having to lock up any capital. You just have to, basically what happens is the stream stays open until your balance runs out. If your balance runs out, then like your stream will get stopped by a node effectively, and that 4-hour deposit will be like slashed. That's how that works. Nice pose, by the way. Yeah, thank you. I think that was a good pose when my video froze. Let me try turning it on and off. Hang on. There we go. I'm back. It works. That's right. All right. Someone else asked, can we start a stream without the entire amount in the wallet? Yep. Again, that's the beauty of no capital lockups. As long as you have a positive token balance, your stream will stay open. That's the heuristic. Let's see. If user stops the stream from the dashboard, will the contract be notified? Yes. If you use the super app example I just gave you, yeah. So if a contract is also on the sending side of, like if you have a super app, right? Like the tradable cash flow example I just used, and it's a sender, that after agreement terminated callback will run if the stream is terminated either by the contract itself or somebody else that's associated with the contract, right? Like that's on the receiving end of the stream or the sending end of the stream. So short answer is yes. If the user goes in and clicks end stream, the contract will be notified and that after agreement terminated logic will run. So you have to be careful about what you put in that logic, or maybe it's good. Maybe you want something interesting in that after agreement terminated logic. Negative stream balance don't get negative. No, yeah. So yeah, exactly. If your stream balance is negative, it means you stream tokens that didn't exist, basically. And there are things built into Superfluid to prevent that from happening. Can a stream compound interest? Yeah. So if you're trying to stream like yield-bearing tokens, the answer is yeah. One thing that you can't do right now is stream inflationary tokens. So I believe with A tokens, with Aave, your balance actually does increase in real time. Those can't be streamed right now due to some things in the protocol. Eventually that will maybe not be the case. You can maybe do interesting things where you have like a separate contract that enables A tokens to be streamed. We do think it's possible, and we'd like to see someone build that, like streaming A tokens in some way, or at least being able to give people access to the yield of A tokens within Superfluid. And then if you want to as well, like C tokens, I don't think are inflationary, right? They're just yield bearing, right? So if you want to stream these tokens that represent a claim on, assets that are appreciating, absolutely. We'd love to see more DeFi integrations more broadly. We've started to see a lot of them. And if you want to build something like that, I would personally help you out. All right. Okay. Yeah, guys, I think I'll answer one more question, and then we'll Yao gave some insight into what we're gonna do next. Follow up to Hardeep's question. That is taking credit like we take credit from traditional banks or some other institution. You don't understand. I don't know where Hardeep's. Okay, yeah. So you don't understand how is it possible to create a stream when you don't have the full token balance of your stream in your account. Okay. So a stream, again, if we think about what a stream is one more time, all a stream is you open up a flow to another user at a constant rate of a certain number of tokens per second, right? You don't see anything there about how many total tokens you want to stream, at least not right now. We'll probably have some automatic stream closing functionality soon and things like that built into the protocol. But right now, you just define the flow rate, which is the amount of tokens being sent per second. As long as you have the tokens in your wallet to be sent, like you can keep sending tokens, and you can keep sending tokens at whatever rate you want, as long as the initial deposit required for that rate doesn't require you to put up more tokens than you have for those first 4 hours, right? So you can set a flow rate of $500 per month and send and have just 300 tokens in your wallet. Like you can do that, and you can do that because you're not sending money you don't have. Right? You're not actually going to be able to send 500 tokens if you only have 300 tokens in your wallet. Your stream is going to get closed down as soon as that 300 token is sent, right? But you can open up a stream that's higher than the balance that you have in your account on a per month basis, as long as you're willing to just top up the balance so that it never hits zero, right? That's the key. Just don't let it hit zero. There are some things we're looking at, like that. Not we're looking at, we want people to build that are related to this credit use case that we think are like very cool and very futuristic. So if you want to build Superfluid related like credit applications and things like that, again, something I would personally help you out with and be like really excited about. Cool. Okay. Can I show one more thing here?
Sure.
Okay. I'm not really showing anything. I'm just
Sure.
I want to provide my Discord DM, Sam F Superfluid 0902. You can DM me here on Discord. I'll be active inside of the Ethernals channel. Happy to help. And then we'll also be hosting, like Yao said, a brainstorming session in the DevFolio Gather space next Thursday. And it will be, more than just brainstorming. It'll be team formation. It'll be office hours, all that stuff. So we're happy to help. Thank you, guys.
Thank you, Sam, for such a fun workshop. Thank you, Yao, for answering all the burning questions. Before folks leave, we have prepared a small quiz for you. Here's a link on the chat. One of you who gets all the right answers will be given 1,000 rupees Amazon voucher. The form will be open for 15 minutes and the winner will be announced on our Discord. For now, we will let Sam and Yao go and enjoy their day. For everyone else, we will wait a few minutes before everyone fills up the link. Thank you, Sam. It was a pleasure hosting you. Thank you so much.
Thank you, everybody. It was fun. See ya.
See you.